Hi everyone. Today's lesson marks the last lesson in our polar and vector chapter. We only have one more chapter to go. Woohoo! But this is just an extension. It's application of vectors. The math involved is simply the math you did last week on the intro to vectors exit slip and the vector operations exit slip. So the math is not different. It's just being able to put the context of the problem into that math. So our first example says, in a warehouse, a box is being pushed up a 15-degree inclined plane with a force of 2.5 pounds. Find the component form of the force. So remember, component form means your answer should look like this, where you have the little arrowheads, the horizontal component, and then comma, and the vertical component. So if we draw a picture of what our problem is asking, that's normally a good starting place. So it's saying that you have a 15-degree incline, which remember, that's always measured from the positive x-axis. You can imagine if this was the xy coordinate plane, this would be the positive x-axis side, and it's 15 degrees up. The magnitude of the vector is the force, so this is 2.5 here. If you fill it in and make a right triangle, you can find your horizontal and your vertical component. And again, this is just like last week. So remember, to get this horizontal and vertical component, you just use trig. So our horizontal side is the adjacent side in our triangle, and the 2.5 is the hypotenuse. So if we have, we're looking for adjacent, we have a hypotenuse, that means we want to use cosine. So you can set up this equation here. So you have cosine 15 equals my horizontal component over my hypotenuse, which is 2.5. Cross multiply here, so do 2.5 times cosine 15. Make sure your calculator is in degrees, and you should get 2.4. Now I want to show you this little shortcut that'll always work, because this will help on some of the more complex problems we do. Without even drawing a picture out, to get your horizontal component, you can always do the magnitude, so the force, which in our problem was 2.5, times the cosine of whatever your angle is, so whatever theta is. And again, in this, it was 15-degree angle. So it'll always work for the horizontal component. So our horizontal component is 2.4. Our vertical component, that's opposite our angle. And again, we know our hypotenuse is 2.5, so we could use sine. So we can set up this equation. Sine of 15 equals my opposite side, which is the vertical component, over the hypotenuse, which is 2.5. Cross multiply. So in your calculator, type 2.5 times sine 15. You should get 0.6. And again, in blue here, this will always work as a shortcut. To find the vertical component, you can just do your magnitude times the sine of the angle that they give you. So again, ours was a magnitude of 2.5. They gave us the angle as a 15-degree incline. So we put those in their respective places. So our answer to this is just the 2.4, 0.6. Next example. A force of 40 pounds acts on an object at an angle of 85 degrees. So at this point, it's almost exactly what we just did. But now a second force of 55 pounds acts on the object at an angle of 30 degrees. So it's say like you're pushing something, and then something comes from a 30-degree angle and pushes it with a force of 55 pounds. So obviously it's going to cause the thing to turn or move in a different way. And we could have this where there's multiple forces acting on it. It might not just be two like this one. You may see a problem where you have 3 forces acting on it or 4 forces acting on it. But you would do the same thing, and I'll explain that at the end. So it says find the component form of the resultant force, which remember from last week, resultant force means that it's the answer to an addition problem. So we know we're going to be adding these 2 forces together. And again, if there was another force, you would just add that third force on there. So we're going to use our shortcuts to do this. This is essentially like the last problem. We just have to do it twice. So we have to figure out the horizontal and vertical components of this first vector, the one with the force of 40 at an angle of 85. So remember, to get the horizontal component, we do the magnitude times cosine times the angle. And then to get our vertical component, we do our magnitude times sine times our angle, which was 85 degrees. Now, since we have another force acting upon this object, we're going to add it to it. So again, to get our horizontal component, we do our magnitude, which is 55, times cosine times your angle, which is 30. To get your vertical component, you're going to do 55, which is the magnitude, times sine times our angle, which is 30. And again, if there was a third force, you would just add that here. To get your final answer, this is like the vector operation exit slip you did last week. I would do in your calculator, what is 40 cosine 85, and add it to 55 cosine 30. You should get 51.1. So all the yellows go together. Then we're going to add the vertical components together. So what's highlighted in green. So we're going to do 40 sine 85 plus 55 sine 30. You should get 67.3. And that would be your answer to the first part on example 2. It just wants the component form. So once something pushed with a force of 40 pounds at an angle of 85 degrees, but something else comes up and pushes it with a force of 55 pounds at an angle of 30 degrees, our object now has a component form with a horizontal component of 51.1 and a vertical component of 67.3. So that's where it would be located. For part B, it says to find the direction and the magnitude of this resultant force, which is the answer in part 1. So again, the math to this is what we did last week, but it doesn't hurt to explain it again. So remember, when you're drawing a vector, the tail is always at the origin. To figure out where the head is of our vector, we use our component form. It tells me to go a horizontal distance of 51.1 and a vertical distance of 67.3. So that's essentially what that coordinate is up here at the head of our vector. We now have this right triangle, which we can use to find the direction. It always will make you use tangent then, because you're always going to know the opposite and adjacent side. So to figure out the angle or the direction, we use arctan. So in our calculator, you're going to do arctan of our opposite, which is 67.3, divided by our adjacent, which is 51.1. So when you type this into your calculator, as long as you are in degrees, you should get that angle is 52.8 degrees. Remember, to get your magnitude, you're essentially finding the hypotenuse of this right triangle. So the shortcut of it is to always just take the square root. It's like you're doing the end of the Pythagorean theorem, where you, at the end, to solve for c, you would take the square root to get the c by itself and no longer have the square on it. So we do the square root of one of our legs, 51.1 squared, plus our other leg, 67.3 squared. When you type that into your calculator, you should get that the magnitude of this vector is 84.5 pounds. All right, and here is example 3. All right, it says a plane is flying 10 degrees west of north at 80 meters per second. There is a crosswind 30 meters per second that is blowing 15 degrees north of east. So we have two different, we have the way our plane is flying, and then we have a crosswind acting on it as well, which is another force. So we're going to have to add these two forces together to figure out where our plane is. It says to find the component form of the resultant velocity. So a couple things to think about is, of course, remember, it goes north, east, south, west. In our first part here, it says a plane is flying 10 degrees west of north. So if this is north, straight up and down, it's 10 degrees west of that. So 10 degrees to the left. So if we know going straight up and down north would be 90 degrees, and you're 10 degrees more to the left, going to the west, your angle, your theta, is 100 degrees. And you know your magnitude is 80 meters per second. Okay, and then we have to add this other force to it, because we have a crosswind and it has a magnitude of 30 meters per second, and it's blowing 15 degrees north of east. So if this is east at 0, 15 degrees north of it would be going up. So it's just this little 15-degree angle here. So just like the last example now, you can do your magnitude times cosine times your angle to get your horizontal component. Then do your magnitude times sine times your angle to get what's happening vertically. Then we're going to add to it this crosswind. So this is changing us horizontally. We would do our magnitude, which is 30, times cosine times your angle, which is 15. And vertically, this is affecting us 30 times sine times 15. Put it in your calculator. You're going to do 80 times cosine of 100 plus 30 cosine 15, and you should get 15.1. When you do your vertical component, do 80 sine 100 plus 30 sine 15. You should get 86.5. So this is the component form of our velocity once this crosswind has acted on our plane flying. Part B says to find the direction and magnitude of this resultant velocity. Again, this is just like example 2. So if we draw a picture, our tail is at the origin here. The head of our vector, I'm going to have to go right 15.1 and up 86.5 because that's what the component form was that we found. So that's the coordinate of the head of the arrow of our vector. Again, to find the direction, what this angle is here of our vector, we're going to use arctan. So in your calculator, you're going to type arctan 86.5 divided by 15.1, and you should get that theta is 80.1 degrees. Again, to get the magnitude, we're using the Pythagorean theorem. We're essentially finding this hypotenuse here. So we do the square root of 15.1 squared plus our other leg, 86.5 squared. And when you type that into our calculator, due to that wind, we were traveling 80 meters per second. Because of this crosswind blowing north of east at 15 degrees at 30 meters per second, our magnitude is now 87.8 meters per second. And I think we're going to skip part C. So that should be good. This is all you need to complete your review and your test. And that's it. If you have any questions, do not hesitate to email me, text me, stop in to a help session. I miss you all very much. I can't believe I'm not going to see you again this school year. All right. Have a great day.